Hi everyone, welcome to Projectile Motion. This time we'll be learning about projectile motion through the story of Rolyna.
Hi everyone. So for this chapter, we're going to be talking about the adventures of Rolyna. So this is Rolyna here, and Rolyna is a cave woman in the land of Talapia. Recently, Rolyna's cave family was killed by a ferocious one-eyed lion right here. This left Rolyna filled with a mix of rage and sadness, which caused her to spend most of her time in the mountains looking for the one-eyed lion and wandering aimlessly. So the example problems we're going to be doing is having to do a little bit with this story. So let's see how it all turns out. First, let's do a conceptual question. We have a ball here. How will the ball roll off the cliff? Will it be like A, it will roll like this and then fall down? B, will it go like this and then fall straight down? Or will it be like C, will it go kind of like diagonal motion? Okay, so you could think about that. It's something we see every day in our lives, but we really don't know how it moves. And what we should know is the correct answer is C. So it's going to move like C. And what we want to know in projectile motion is it's going to be moving in both the X direction and the Y direction. In the Y direction, gravity is going to be pulling it down. But if something has been moving towards the right, it's always going to be also moving in that right direction. So it's not going to be like cartoons where they run and then fall down. It moves like C right there. Okay, example problem number 1. Rolyna is practicing her javelin throw. She throws a spear 30 meters per second towards a bullseye directly in front of her. The spear takes 0.28 seconds to reach the target. How far is the target from her? So in this question, what we're trying to figure out is what is this distance right here? And when we're dealing with projectile motion problems, they can be a bit difficult because it has to do with 2 dimensions. So what we want to do is we want to separate everything in the X dimension and we want to separate everything into the Y dimension. So what we're going to do is we're going to make an X direction here and a Y direction here. And we want to see everything we know in the X and everything we want to know in the Y. And what I like to start out with is acceleration. Acceleration in the X direction is always going to be 0. There's nothing that's going to be making the spear go faster while it's in the air in the X direction, and there's nothing that's going to be making it go slower in the air because we don't account for air resistance in physics at the beginning. And acceleration in the Y direction is going to always be counted for by gravity. So gravity is always something that's going to be pulling it downward. And what we're going to be using, instead of negative 9.8, we're just going to make it simple by using negative 10 meters per second squared from now on. Okay, next thing that we know is she throws a spear 30 meters per second towards a bullseye directly in front of her. So she throws this like this, 30 meters per second. And if we notice, this is all in the X direction. So this is all in the X direction. So we can say the velocity in the X is 30 meters per second. And the spear takes 0.28 seconds to reach the target. So the time is the only thing that's going to belong to both of these. So we know in the X direction, the time is 0.28 seconds. And the Y direction, it's 0.28 seconds. Okay? Now, how far is the target from her? So what we're looking for is how far is going to be the distance in the X direction. So since we have 3 pieces of information here, we can find what that distance in the X direction is going to be. We're going to look at a formula and we're going to see which 4 has these 4 variables, and we're going to see that the displacement in the X, V initial xt plus 1/2 axt squared. And what we're going to do is we're going to plug everything in. So displacement is equal to velocity initial x, 30 times the time, 0.28, plus 1/2 acceleration, which is 0, t, which is 0.28 squared. But this turns to all 0. And then we get the displacement is equal to 8.4 meters. Okay, so that's the answer to the first one. So projectile motion is all about organizing your information. Once you can organize everything, you should be good. So part B is, by how much does she miss the bullseye when the spear hits the target? So one thing to know is when she throws this straight, what's going to happen is gravity is going to pull it down. So even though she's aiming straight, what's going to happen is the gravity is going to pull it down somewhere like this. And we're looking for how much does this fall in the y direction. So what we're looking for is the displacement in the y direction. However, we only have two pieces of information. So this is a little bit of a trick, or something to know, is whenever something is being thrown directly horizontally like this, that means we also know what the initial velocity in the y direction is going to be. And if it's going directly horizontally like this, that means we know at the beginning the initial velocity in the y direction is going to be 0 meters per second. So now, using this information, we can find what the displacement of the y is. We have the same variables, but now we're just going to be using it for the y. So displacement in the y is equal to v initial yt plus 1/2 ayt squared. And it's very important when you're solving, when you're using y, only use the y variables. When using x, only use the x variables. The only thing that can be shared is the time. Okay, so displacement in the y is equal to the initial velocity, which is 0, time, which is 0.28, plus 1/2 negative 10 t 0.28 squared, and we're going to see that it's going to be falling, so it's going to be negative 0.392 meters. So how much does she miss the bullseye when the spear hits the target? It's going to be 0.392 meters below the target. Okay. And when Rolyna meets the one-eyed lion, she realizes that she cannot aim directly at it because of a magical spirit that pulls everything downwards. Interesting, this magical spirit. All right, let's look at the next example. Example 2, projectile motion, 0 angle. Rolyna climbs to the top of a mountain and decides to pay tribute to her god Rogar. To make an offering, Rolyna finds the prettiest rock on the mountain and throws it so that it hits the ground 100 meters away from the base of the cliff. If she is 200 meters above the ground and she throws the rock horizontally, with what velocity does she throw the rock? Okay, so with a problem like this, I want to draw it out. So this isn't really the best angle, so I'm just going to draw it out here. Rock is thrown and throws it out directly horizontally, which is important. And we see that it hits the ground 100 meters away from the base of the cliff. So 100 meters. If she is 200 meters above the ground, so 200 meters above the ground, and with what velocity does she throw the rock with? So we're looking for the velocity. Okay. So again, what we want to do is we want to find what all our information is in the x direction and the y. And we always want to start with acceleration. Acceleration to x is 0, and acceleration to y is going to be gravity pulling it down, negative 10 meters per second squared. Okay? No air resistance, so it's just 0. What we also know is this rock is going to be falling down 200 meters in the y direction. So displacement in the y is equal to negative 200 meters. We know that this rock is going to go in the x direction 100 meters. And that seems like all we know. However, there's another thing. We know that she throws this rock completely horizontally. What that means is the initial velocity in the y direction is going to be 0 meters per second. This is because she's throwing in the x direction only, so at the beginning the rock isn't moving at all in the y direction, so the velocity initial in the y is 0. What we're looking for, however, is what this velocity is in the x direction, because she throws it in the x direction, so we're looking for what that initial velocity is in the x direction. The problem is we only have two pieces of information. So if we only have two pieces of information, we need to find another piece of information to find this. But we do have three pieces of information here, so we need to find something here that's going to help us with the information here. And the only thing that's going to be the same for both of these is going to be time. So if we can find the time using this information, that'll also give us the information for time here. So we're going to look for time. Again, we're going to look at our formula and we're going to see which one has all 4 of these variables. And we see again that it's this formula here that we're going to use. This is probably the most popular formula. So we're going to use that. So we're going to do displacement in the y equals initial velocity in the y, t, plus 1/2 ay t squared. Negative 200 is equal to 0 plus 1/2 negative 10 t squared. Okay, do a little bit of math. Put this 2 over here, so it's going to be negative 400. And then it's going to be divided by negative 10 is equal to t squared. Square root both of these. And then we get 6.32 seconds. Okay. So we get this is 6.32 seconds. This is 6.32 seconds. Now, what we have is we have 3 pieces of information here, and we can find what this velocity in the x direction is going to be. I'm going to use a different marker. So again, we're going to look at our formula sheet, see which one has all 4 of these, and it's the same formula once again, but now we're just going to use for the x. Remember not to mix up any of the variables. This is why we make this chart, so we don't mix up any of the variables. Displacement of the x, 100. Velocity initial, that's what we're looking for. Time we know is going to be 6.32 plus 1/2, and the acceleration is 0. 6.32 squared. This just turns to 0. So now we're going to do 100 divided by 6.32 equals the initial velocity in the x direction. And what this is going to give us is, this is going to give us 15.81 meters per second. Okay. So, what happened with Rogar? Did he accept the offering? Actually, Rogar was sleeping and did not notice the offering. So, that was kind of sad. Sorry about that, Rolyna. Alright, let's look at the next example. Example 3, projectile motion. Rolyna finds the one-eyed lion, and starts to sneak up on it. The lion notices Rolyna and starts to dash away. Rolyna throws her spear and impales the lion. Having no choice, the lion runs off the cliff with a horizontal velocity of 8.6 meters per second. He falls into a lake 20 meters below. So let's kind of, runs off the cliff 8.6 meters per second. The cliff is 20 meters high. How much time will it take the lion to fall from the edge of the cliff to the surface of the water? Alright, so again, we want to organize everything. So we want to see everything that's in the x direction and everything that's in the y direction. What we know is the acceleration. Again, we want to start with acceleration. The x is 0. Acceleration to y is gravity, negative 10 meters per second squared. Next thing, the line runs off with a horizontal velocity of 8.6, so that means in the x direction. So velocity in the x is 8.6 meters per second, and he falls into the lake 20 meters below, so it's going to be falling 20 meters. So that's going to be displacement in the y is going to be negative 20 meters. And what we're looking for is time. Okay, time is something that's for both of them, so I'm just going to put it there. So it looks like we only have 2 information for both, but again, realize when he's moving horizontally, that means when he steps off this cliff, he has an initial velocity in the y direction of 0. So we have to also know when he's moving only horizontally, that means the initial velocity in the y direction is 0. Again, we're going to use our formula. We see this is the one that has all 4 of these variables to find time, and we're going to use that. Displacement in the y is equal to initial velocity in the y, t plus 1/2 ay t squared. And then we have negative 20 is equal to 0 plus 1/2 negative 10 t squared. Okay, put that to the other side. Negative 40 divided by 10 square root equals t squared. Oops, sorry, this is negative 10. And then we do a little bit of math. And we see that this guy the lion is going to be falling in 2 seconds. It's going to hit the water in 2 seconds. Okay. Part B, how far from the base of the cliff will he strike the surface of the water? So we want to know how far from the base of the cliff he's going to be striking the surface of the water. Okay, so we're looking for what this displacement, the x, is. And now that we have 3 pieces of information, we have acceleration, velocity in the x, and the time, we can find the 4th piece for the displacement. Using that same formula again, displacement of x, but now for the x. T plus 1/2, a t squared. Displacement, that's what we're looking for. Velocity is 8.6. Going to be falling for 2 seconds, plus 1/2. Wow. But this is 0, 2 squared. This all goes to 0. And we see that the displacement is going to be 17.2 meters. So this line is going to be going 17.2 meters in the x direction. Okay. Part C says, what is his landing speed? So this is important to know. First of all, what we should know is this line is going to be running off horizontally. So in the x direction, there is no acceleration. And what that means is the lion is always going to be going in the x direction 8.6 meters per second. However, in the y direction, as we know, at the beginning, it's going to be going 0. But as it falls, it's going to be going faster and faster and faster. Okay? Because of gravity, it's going to be pulling it faster and faster and faster. So, important to know, we know what the velocity is in the x direction when it hits the water. It's going to be 8.6 meters per second. But we want to find what the velocity is in the y direction when it hits the water. So what we're going to be looking for is the velocity final in the y direction after 2 seconds. Maybe I will use orange for this. So we're going to use our formula to find out what this velocity final in the y is. And we have a few options, but I'm going to use this one right here. I'm going to use that one right there. So I'm going to do Vf squared is equal to V initial squared plus 2a change in y. So velocity final in the y is what we're looking for. The initial velocity is 0 squared plus 2. Acceleration is negative 10. And the displacement in the y is negative 20. So we get, this is going to be equal to 20 and then 400. And this, since this is squared, let's square root both of this, and we get the velocity in the y direction is going to be 20 meters per second. So that's just in the y direction. However, we know that it's also going to be moving in the x direction. So we know in the y direction it's going 20 meters per second downwards when it hits the lake, and it's going 8.6 in the x direction. So what we have to do is we have to combine both of this. And how we're going to combine is not adding, but adding these two vectors. So we're going to do 8.6, and then the other vector, 20. And then what we're going to do is we're going to find that resultant vector. Okay, so we know the resultant vector. We're just going to do Pythagorean theorem. It's going to equal to 20 squared plus 8.6 squared and the square root of that, and that gives us 21.77 meters per second. Okay, so just know when it's asking for the speed, the landing speed, that means the combination of both the x and the y. Okay, but what happens is there's these little lines here. What's going on? Rolyna does not notice the line resurfacing from the water. However, on her way back home, she notices 3 baby lion cubs, each with only one eye that have not opened yet. Oh no, what's she going to do with the cubs? Rolyna thinks about throwing each of the cubs over the edge with their father, but realizes that wouldn't be very nice. She readies a pot of boiling water and feeds each of them some pumpkin soup. Alright, that's it for this lesson.